Hey everyone, here's our last round of notes for our proof unit. Woohoo! All right, we're gonna be doing 3 examples today. The first one, we're gonna start with a nice 2-column, but today we're gonna learn about what flowchart proofs are. So we're gonna do 2 of those examples together. All right, here's our first example of the day. It says we are given that NL is equal to NM. So we know that NL, this whole thing, is the same as NM. Okay. We were also told that AL is the same as BM. And our goal is to prove that NA is equal to NB. Sounds like a plan. So here's our proof. All right, we got to fill in the reasons today. So it says that NL equals NM and AL equals BM. Well, that's our given. Number 2 says that the whole thing NL equals NA plus AL. All right, so it's taking part of that segment plus another part of that segment equaling to the whole big segment. Well, that sounds like segment addition postulate. Number 3 says NM, the whole thing, is equal to NB plus BM. Okay, that sounds like segment addition postulate again. They then said that NA plus AL equals NB plus BM. Where are they getting that information from? So NA plus AL. I see that up here. That equals NL. So they said that NL, all right, is equal to that. And remember, NL is also up here. We also know that NL is equal to NM. Well, NM is NB plus BM. So what they do is they substituted in those equations. So they substitute this in for that and this in for there. So I would call that substitution. From the next step, all that looks like that changed was the BM became AL. If you remember from our givens, those are equal, so they substituted again. Okay. And it looks like they just got rid of the ALs finally, so they subtracted AL from both sides. And that is how they proved that NA equals NB. Awesome. All right, flowchart proof time. Now, guys, flowcharts are my absolute favorite. And like I said in the very first video, some people don't like them because they're a little bit kind of crazier. They're not as organized, all right? But I think it helps me kind of visually see what's going on there. So we're going to do 2 examples together, and we're going to do a ton in class as well. All right, so we got this lovely picture over here. Our given is GD bisects angle CBE. So let me find GD. GD, this line right here, bisects angle CBE. Well, if it bisects angle, what do we know about bisectors? What do they do to that angle? They cut them in half. So I know that this half of the angle is the same as this half of the angle. There should be equal. So how flowcharts work? The statement goes in the box. Your reason's going to go underneath. All right, so the first one says GD bisects angle CBE. Well, how do I know they bisect? It was given to us. We're going to follow the arrows. We're going to follow the arrow here. So the next reason has to do something with that. So since they bisected, what did we now know then? Well, we knew that those 2 angles were equal. So the measurement of angle 3 equals the measurement of angle 2. And how I knew that is because the definition of an angle bisector. We're going to follow the arrow again. It comes down to this one. But this one has another arrow, so we got to come up here. It's an empty box there. Our goal is to prove that angle 1 and angle 2 are the same. So we have to somehow bring in angle 1 to this program. If you look at angle 1, how does angle 1 relate to any of the previous angles that we have there? Well, I don't know if angle 1 and angle 2 relate to each other right now, but I think angle 1 and angle 3 relate to each other. What types of angles are angle 1 and angle 3? They're vertical angles, so they're equal to each other. So I said angle 1 is equal to the measurement of angle 3. The reason is the vertical angles theorem. I shorten that to VAT, vertical angle theorem. And what I'm doing there is I'm taking those 2 equations because they both equal the same thing. Look at these equations. I have the measurement of angle 3 equaling the measurement of angle 2. and then measurement angle 1 equaling the measurement of angle 3. So they both equal the same measurement, so I can just combine that into 1. So when I take two equations down into 1, that is the transitive property. All right, if you said substitution, I wouldn't take off any points for that either. Just the more correct answer would be transitive there. And we've completed our first flow chart. If you hate it, I will not be offended, guys. It's okay. It's a tough one. I just think it helps kind of connect the ideas a little bit more for me. All right, let's try another one. This is the big one. All right, it says we are given that AB is 2x, BC is 4x, and AC is 36. Our goal is to prove that the length of BC is 24. I'm going to mark up my picture first. So AB is 2x, BC is 4x, and the whole thing is 36. So I'm thinking we're probably going to make some type of an equation here. Now, before we throw in the numbers, we actually have to write the equation with the words. So I can say that AB plus what? Plus BC equals the whole thing AC. My reason behind that is the segment addition postulate. All right, step number 1 done. I find the number 2. Number 2. All right, I probably need to list out all of my givens. So AB equals 2x. BC equals 4x. And AC equals 36. And those are just my givens. Now, both of these boxes, if you look, are coming to this next one. So we're going to combine both these boxes into one box. How do we do that? But we're just going to be plugging in those values. So I can say 2x plus 4x equals 36. What is it called when you plug in values to an equation? Substitution. All right, time for the math time. What would you guys do next here? You're probably saying combine like terms. What is 2x plus 4x? That gives you 6x equals 36. What is that called when you combine like terms? Simplify. I'd probably divide by 6 now, so I get x equals 6. That would be the division, POE. All right, now if you look at here, is this next box is coming from 2 areas. It's coming from here, and it's coming from here. All right, so we're using that x equals 6 in one of our original givens. So if you look back at our thing, we're trying to prove that BC equals 24. So I bet you what we're doing here is we're taking that BC equals 4x, but instead of that x, we now know that actually is 6. What is that called when you replace the value there? Substitution. Okay, we're going to say that BC equals 4 times 6 is 24. What is it called when you combine like terms there? Simplify. And we have done the flow chart. All right, again, I'm a huge fan of these. I think it makes more sense. I would never make you make one of these all by yourself. I will always give you kind of the boxes and the arrows, but they're my personal favorites. I'll see you guys.